delta T and the required flow rate, we have to make a parallel and series combination, and we have to design according to the rooftop. We have to design vice versa, and we will look all the safety features while erecting of the structures, safety belt and catwalk and all other things. Now we will go to this integration part of the thing. Integration means the solar system with your existing heating system. So existing heating system will be a thermic fluid boiler or electric heater or hot water generator type. In hot water generator type, we will move with plate type heat exchanger, so that the heat transfer fluid is coupled to the plate type heat exchanger and easily retrofitted. But if it is thermic fluid type, cannot couple with thermic fluid because of very high temperature. Operating temperature is around 260 degree. So we will couple through coil type version. Normally paint shop process diagram will be first wash and then knock off degreasing and degreasing and rinse, after that phosphating, and this process will come to an end with oven packing. This is the normal pre-treatment tank facility everywhere in industry for painting purpose. And here is existing, if it is thermic fluid type, the existing coil will be using thermic fluid, heat will be transferred to the process liquid, and we will put our solar thermal coil in the tank itself, and the space and all other things we have to calculate, and we will put our valves and all other things according to the figure shown in this. This type of coil we have to place for thermic fluid type of thing, and this type of plate heat exchanger is for hot water, pressurized hot water circulating boiler. And this is the hot water boiler, and from this the hot water, pressurized hot water will go to the process, and we have disconnected here, and it is fed to the solar heat exchanger, plate heat exchanger, and solar plate heat exchanger, and it will be retrofitted
Sorry for that. So basically, in this particular case, the tank itself, the tank where the heat needs to be transferred, from the tank, we are taking the fluid out, and through the heat exchanger, heating that liquid and putting it back into the tank. That's the way it is done here. So that's an external plate type heat exchanger, PHE, and this is actually slightly more complicated than if you are inserting the coil directly into the tank, because there is no need for, I mean, in this particular case, you are taking dirty fluid from inside the tank and heating it up. So filtering and putting it back and all of that becomes an issue, and you're introducing a new pump here. But in some places, like they were mentioning, Managing Director of Philips India was mentioning, in some places where there is a risk that getting interruption because of any leakage, if there is a bigger risk, that's one side of it. The second side of it is when there is space constraint. In many cases, we find that the components are being cleaned are almost occupying the tank, and so there is no enough space inside the tank for inserting the solar coils. And in those cases, we use an external heat exchanger to transfer the heat from the solar system into the tank, and so it's basically a tertiary system. Already we are using a secondary system, it's a tertiary system, so 3 heat transfers here. But in many industries, we find wherever they are using hot water generators, we find that already such systems are in place. So already the tank is not where the heat transfer takes place, but the heat transfer is in the external painting. It becomes very easy to integrate in those cases, although it is complicated, but the complication is already handled by the existing plant. So all we need to do is interrupt the flow from the existing hot water generator, insert our solar coil, and she will show you a couple of schematics on how that works. And we are also working on air heaters, fundamentally radiator type systems, where, so the moment you generate, a lot of people come back and tell us saying, okay, I mean, it may work for a Sonokoyo, it may work for Philips India, but ours is different, and that's something that we want to disagree. The moment you achieve a 100 degrees or a 90 degree temperature using the solar system, now that's the primary heat source. It becomes a primary heat source. Now you can transfer it to any kind of medium using any heat exchange technology. So we are working on a fin type air heating system right now as we are talking. Now this is how the retrofit typically works, very simple. When the sun is not shining enough, the temperature of the solar system is not sufficient. The existing system is working through its hot water generator or whatever the existing sources. The moment that we sense the sun, the solar temperature, what is generated out of the solar, so the temperature sensors are placed here, and so we sense the temperature. The moment the temperatures are achieved, we reroute it. Next one. So we reroute it, by which the existing system is cut off, and the solar system through the heat exchanger or the coil type coil inserted inside the tank is what is circulated to transfer the heat from the solar system